Welcome to The Dirt on Geotech. Today we're digging into a formula that every civil engineer has scribbled in the margins of their field notes at least once. We're talking about the Hazen equation, a cornerstone of hydrogeology developed by the American chemist and civil engineer Allen Hazen in the late 19th century. While we have fancy sensors and computer models today, Hazen's work in the 1890s provided one of the first reliable bridges between soil texture and how water actually moves through the ground. Hazen's breakthrough came while he was working for the Massachusetts State Board of Health, specifically focusing on water filtration. He realized that the speed at which water flows through sand, the hydraulic conductivity K, wasn't just random. It was deeply tied to the size of the grains. He observed that the smaller particles in a soil sample had a disproportionate effect on flow because they choked the pore spaces. This led him to define the effective size, or D10, which represents the grain diameter where 10% of the sample is finer by weight. The beauty of Hazen's work lies in its simplicity. He proposed this empirical formula in strict U.S. units. K represents the hydraulic conductivity in feet per day, while the effective size D10 is typically converted from sieve sizes into inches. When we look at the math through the lens of U.S. customary units, the coefficient C has to be adjusted for the change in scale. While the standard C of 1.0 is used for metric centimeters per second, in the world of feet and inches, the value is shifted to account for the vastly different units of time and length. For a typical clean, loose sand with an effective size of 0.01 inches, the formula allows a technician to quickly estimate how many feet of water will move through that strata in a 24-hour period. In the field, this simplicity is a lifesaver. If you are standing on a site in the mid-Atlantic and need to know if a specific sand layer can handle drainage for a foundation, you don't always have time to wait for a lab. By using the D10 value from a standard sieve analysis, an engineer can estimate the permeability in feet per day almost instantly. It's a back-of-the-envelope calculation that has helped design thousands of drainage systems across the country. However, the Hazen rule comes with a warning label. It was designed specifically for clean, uniform sands. If you're dealing with a soil that has a high fines content, meaning lots of silts and clays, the formula will overestimate how fast the water moves. In those cases, the small particles don't just restrict flow, they practically choke it off, and the empirical relationship starts to lose its accuracy. Despite those boundaries, Hazen's work remains a fundamental part of the geotechnical curriculum. It's shifted the industry from guesswork to a mathematical standard, proving that the smallest parts of the soil often dictate the behavior of the whole site. Whether you're calculating seepage for a levee or drainage for a highway, Allen Hazen's 19th century observations still provide the framework for how we move water today.